Hello, maybe we can start? Yes, great. Thank you very much for coming to this session. Good afternoon, everybody. I hope you're enjoying the Sea of Solution conference so far, and this is one of the last knowledge sessions. And I hope you still have a bit of energy to our sessions themed Harnessing Innovation, Digitalization, and Power of AI. Explore cutting-edge technological solutions in addressing plastic pollution. My name is Nao Takeuchi, and I'm from the headquarters of UNEP in Nairobi, and I'm leading the development of GPML digital platform there, and then which is one of the digital space for knowledge materials and data management, connecting wide range of stakeholders in the fight against plastic pollution. And I will moderate this session, navigating our 1 hour discussion with you all here. And then, so harnessing innovation and digitalization and the AI. So the rapid development of all these digitalization and AI has opened a new frontiers in the fight against plastic pollution. And in these technological advancements offer many opportunities for innovation, monitoring, data analysis for more informed decision making. And today, we will see various innovations happening in preventing and reducing plastic pollution, from digital tool used to bring transparency and traceability in the waste and the circular economy chain, and then also AI-powered robotic system used for waste sorting, to data portal of plastic leakage data in cities to inform policies and actions, inviting key speakers from here, from GIZ, ASM Global, and TOMRA. So we will have a Q&A session after the presentations. So we look forward to a vibrant discussion there. So please feel free and feel safe to ask any questions you have. So now I first would like to invite Ms. Jore, and founder and CEO, ASM Global, for her presentation on RecycleX, traceable plastic circular economy. Surbhi, maybe could you introduce yourself and then go on your presentation? Floor is yours.
So good afternoon, everyone. My name is Surbhi Jore. I am the founder and CEO of ASM Global, essentially a software company developing the track and trace software for circular economy. And it has been wonderful 2 days of brainstorming around how we can collaborate and channelize the resources to co-create the solutions in the space of circular economy. But it's wonderful to see that on the left-hand side, you can see there are these bottles when they claim that they are made with the recycled material. It is also, of course, it is very wonderful to see that there are initiatives coming up with those recycled contents into the manufacturing, but it is also essential that we ensure, or they are able to prove that there are the evidences of equitable distribution of economic value is available, or the workers are paid fair wages, and there is no marginalization in particular. Of course, these materials are stored and processed in the EHS compliant facilities. And of course, there are the claim provenance. There is a verification mechanism that exists to track the content claims, right? So what we have seen so far, of course, there are some traceability systems that do exist, but most of them are either manual or lack some kind of transparency, or the chain of custody is broken. So when these product sustainability claims are made, they should not only be sustainable, but they should also ensure that the material is sourced ethically, the products are made responsibly, and they adhere to the highest level of standards. For example, we comply with the ISO 22095's chain of custody, or ISCC standards, WERA, or there are so many standards that do talk about the traceability into the circular economy. What generally happens when these systems are either manually made or they are point solutions, they lack some sort of accountability when the data is transferred between different stakeholders. So there is always the blind spot that gets created, and that makes this entire chain broken at some point or the other. So what Recyclix does? Recyclix, of course, works on the chain of custody standards of ISO 22095, where they follow the simple process of collect, sort, recycle, and convert into the new product. But what essentially happens when we collect this material, it has to be ensured that what was collected, when was it collected, what was the location where it got collected, who collected it, and how they collected it. And all of this at every step when we move forward in the supply chain, without losing or without creating that blind spot when the material is moved into the hands of different stakeholders. So that's what Recyclix ensures. It not only enables the unique digital identity of each stakeholder, but it also ensures that what all the records that are created, that are immutable, they are tamper-proof, and the system is capable to verify or audit those records, as well as it works on the wallet-based system. So all those claims that are made cannot be made again and again. So that reduces the chances of, or it eliminates actually the double count or the fraudulent practices. So, and on top of it, like what Recyclix offers is, of course, end-to-end real-time material tracking for circular business models. It offers the collaborative data collection with multi-factor data validation algorithms across the value chain. It is based on ISO 22095. It works on the dynamic QR codes, and it is integrated with the blockchain. So it helps on real-time data for decision making that could be effective for EPR or any kind of circular business model that includes refurbish, repair, or refill kind of system as well. And ultimately, it issues the digital product passport. So this passport could use multiple tools through which you can actually just scan the QR code and tell you the entire material journey of all the components that is making that final product. So that's what the Recyclix offers. As ASM Global, so far, we are present across 35 countries, right from all the way from North America, European Union to Asia, ASEAN, and currently catering 25 plus clients, still counting. And we are able to track 600,000 plus tons of material through our platform. So that's largely about it, and happy to have the questions. Thank you.
Thank you, Surbhi, for the very inspiring presentation. I think now it's really interesting to see that digitalization is a kind of like advancing and becoming important to track the value chain of the waste, whether or not that is handled in a just and in a fair way. And then I think there are lots of implications on how EPR systems should be designed, and then also can be, this digitalization can be a tool for the enforcement, for example, for the regulating such kind of the EPR system. Thank you so much for the presentation, Surbhi. And we're going to have the Q&A session later, so please hold your questions for the later session. And now I'd like to invite Mr. Chang, Vice President Public Affairs from TOMRA, for his presentation about AI technology used in sorting process for efficient and effective recycling processes. Jet, floor is yours.
Thank you, Nao. I used to, normally I do the speaking and try to stand up and walk around, but now with this setup, I think I will have to sit here. I'll try to get used to that. So my sharing will be mostly focused on the technology and especially on the so-called AI. I want to make it clear now that when we are talking about AI, we are talking about more about the perspective AI, not the generative AI, which is like a ChatGPT. perspective, AI is something to help you to get a better knowledge of the things. And here we are talking about getting a better knowledge of the material. Sometimes, it's the post-consumption packaging, if it's a plastic, paper, or whatsoever. So, well, Tomra as a technology company, innovation, digital AI is something actually, especially innovation, it's deep in our hearts. It's one of the major values, one of the three values points that we have been kept for the past 52 years, and we also have been given the award for the innovation. Tomra, as a company, we started 52 years ago as a collection machine, which is now we call reverse vending machine, or RVM. You can see from the picture in the left-hand side, the first prototype was to actually collect the glass bottles for refill or reuse models back in the 70s. And then, of course, with the new materials like paper, plastic, aluminum comes up into the packaging, we also start to, you can see our new machines is able to collect not only glass, we also collect plastic bottles, metal cans, Tetra Pak, or liquid paperboard for recycling or reuse. Then briefly about the business segments we have, collection is one of the major business, reverse vending. We also do a lot of sorting. You can see we sort for the recycling, plastic waste, paper waste, metal waste, municipal solid waste, organic waste. We have technology to sort them for recycling. We sort for the food production, apples, berries, whatsoever. One of our new initiatives is also we are now working on sorting waste textile for recycling, second-hand clothes, polyester, cotton, whatsoever. Yeah. So we are very much about digital and AI. AI is very much being used in our reverse vending business, collection business, basically to help you to have a better understanding of the operation of the collection network, how to maintain the machines, how to improve the performance. And we also use a lot of AI in the food sorting segments, basically, to have a better idea, if a given apple, if it's mature enough, if it's half mature, or if it's already too mature, if it should be used for the near market, or it can be put into a container for long distance or longer shelf life. We also actually do mining. We also have AI technology to have a better understanding of the ores, which we sort them. For example, just recently, through Tomra machine, we identified and found the world's second largest diamond, which is 2792 carat. So it's the second largest stones ever known to the human beings. And it is through our technology, and we are actually quite proud of that. But today, I want to share more about the waste sorting for recycling. Tomra, we have been, as a technology supplier, very much used to be focused on the so-called sensor-based sorting, which, as we sometimes also call it optical sorting. So we use the optical signals to identify the material on the belt to understand if it's plastic or if it's paper or other thing. And also among the plastic, we use the optical sensor to identify if it's a certain type of polymers, for example, PET, PPP, LDPE, PVC, PS, you can go on for that. So here I want to show you a quick video about how this sensor-based sorting works. I hope it can be played. Yes. So you can see that the input is a mix of everything, like a household solid waste or municipal solid waste. Then you put it onto a belt. Then you have the light being strapped on the belt. Then we take the reflection light, and then in the near infrared spectrum, we do the analysis of the reflection light, trying to understand, based on the reflection in this spectrum, we are able to tell what kind of material it is. Then, of course, on top of that, we have the so-called objective identification. So we know it's an object, it's a bottle, it's a cup, it's a piece of film or something like that. So we know the polymer type, the material type, then the size, the shape, the structure. Then you have the algorithm behind it to be able to give a decision if this is a certain object that we want to sort it out. It's a targeted material or targeted object. And this is fully automated. It has been in the market for the past 30, 40 years. and it has been used in many applications. But then, this also gives the illustration how the thing works. You have the belt, you have the sensor, then you have the air compressor to make the sorting activities. Then on top of that, quite recently, we have the so-called GAIN Next technology, which is AI deep learning based, can be combined together with the optical sorter. So then, which gives us the possibility to tell if it's a piece of plastic. We can know if it's a PET or PP or whatever polymer type, but on top of that, with the AI deep learning, we are able to tell if this piece of plastic is food packaging or non-food packaging, for example. This is very important, I want to emphasize here, because we are aiming to use the technology to help us to achieve the so-called closed loop recycling. Closed loop means we want to go bottle to bottle, we want to go cup to cup, we want to go tray to tray, food packaging to food packaging, non-food packaging to non-food packaging, textile to textile, or you can call it the fiber to fiber, right? So it is very important to be able to tell a piece of object or material if it's material type, but also, if it's a food application or sometimes sensitive application or not. So that's, you can see that on top of the traditional sorting machines, we can add another modular, which has the cameras in it, and also, in the software, we have the AI deep learning algorithm. So if you combine that together, that gives us a power to be able to tell, the differentiate the food grade or non-food grade. So this also gives you some kind of illustration. If you have the mix of material on the belt, we can now say this piece is a food material, the other piece is a non-food material. Then this is help us to separate them out. And then we should hope that after that, the food grade will go back into food grade application. I think with the RecycleX traceability technology, that's actually combined. We can really aim for the true circularity. And this is not only for the packaging, we are now extended it to textile. We are now extended it to the end-of-life vehicles, the end-of-life electronics. It will be dismantled, shredded, and then we can also separate the material out for recycling. And hopefully, most of the cases should go for the closed-loop recycling. So this gives you a recent project we are part of. It's called the Next Loop. You see it's a double P, which means polypropylene, PP. A lot of PP has been used in the packaging, not as the PET bottles. You see most of the PET in packaging is in the water bottles. But PP have a much wider applications. It can be used for food packaging. In China, for example, if you order deliver food, right? Many times, it comes with a plastic box. It's a PP in most of the case. But also PP are used in many other applications, non-food application. So if you're doing the recycling, the old technology, the sensor technology is able to tell this is a PP. But now with the AI, we are able to tell this is a PP for food application, which is, as I mentioned earlier, very important. Then we can sort it out. PP packaging food will be recycled back into a PP packaging for food again, and again, and again, okay? So the test or the trial with this project, we can prove that the target of the sorting, we can achieve more than 95% of the purity, and we can sort it with automation at quite a large volume, 5 tons per hour. You can imagine, that's a lot of packagings on the belt, and we can sort them. You can see also this is for other packagings like HDPE, aluminum, and many other applications. So yeah, TOMRA and AI is nothing new for TOMRA. We have been in this using this algorithm and the power of AI for the past 20 years, and now we found the new applications for AI, and we definitely will also continue to invest more into the AI. And on top of that, we are working with new startups. There's a new startup company called the Poly Perception. They use the AI technology, deep learning, to understand the composition of the waste from the household waste or the municipal solid waste. So we are working together with them, which will gain a lot of knowledge into the sorting facilities like a MRF. Then with the better understanding of the composition, then you can have a better operation of the MRF to sort out more targeted material with a higher purity and with, it will actually bring back, a higher return on the investment and also much better, environment benefits and the carbon benefits in the future. So yeah, if you want to understand more, there's a link. If you go to tomra.com and you search for Gain Next, that's you can find more details. Yeah, thank you.
Thank you, Jed. It's quite impressive that now that the AI can really detect that this is the recycling for the food packaging, so it actually can really increase the amount of to be recycled, right? Yeah, that's great to know. Okay, so now next I'd like to invite Dr. Johannes Paul and then Miss Annika Schumann from GIZ. I'm just wondering, like, Annika is online here. Hi, Annika. Great.
Hi. Hope you can
Right. Yeah. So the GIZ colleagues from will be making a presentation about the waste flow diagram, a rapid plastic leakage assessment method enabling reduction of marine litter through data-powered decision making and online portal. So they have now launched the online portal, so that those data coming from the municipal solid waste management might be very interesting to know, to really understand where the sources and the pathways of that plastic leakage is coming from. So first we would like to hear from Dr. Johannes Paul and then move on to Annika. Thank you.
Yeah, thank you. Good afternoon. Pleasure to be with you, and thank you for inviting GIZ to the session. So we switched the topic from something more technical back to the developing context. So we are excited to exchange with you experiences from our waste flow diagram, which was developed really to support and to understand waste leakage in the municipalities in the Global South, and that you understand why we are here. Yes, we have already 150 cases worldwide in 24 countries. And by doing this tool and applying this tool, of course, we generate a lot of data. That's why we are here. And we would like to share how we get the data and also the visions, what we can do with the data, maybe linking to other organizations. So this may be very exciting. Before Annika, my colleague Annika Schumann comes in to give us details, just for you to understand, I was some years back working in a global sector project on circular economy and waste management in Germany, but now I switched for a project 3R Promar, working with ASEAN, so we are really working on the ground, but my colleague Annika is still in Germany in the sector project. This has the name Go Circular, and Go Circular is commissioned by the German Federal Ministry of Economic Development and Cooperation. And Go Circular is also the coordinator of the Prevent Waste Alliance, which you have heard already. There are even some members in the room, I know, who know the Prevent Waste Alliance, which is a body which also helps us to scale up, to promote, to provide knowledge in the field. And the waste flow diagram, as other topics, are also a discussion in Prevent Waste Alliance, how we can provide public goods that help in our development work. So just to give you some reasons, so Annika is from the Go Circular and is now at the moment working on how to use data in more detail, also with digital methods. She will tell us about the waste flow diagram portal, which we develop. But I would just want to summarize you the reason why came we up with this tool. So basically it started in 2017. We had a study. It started in Indonesia and Sidoarjo in Nigeria, where we ask ourselves, how can we help municipalities? GIZ works in many countries, and when you go to a municipality and you talk to the decision makers, you will find out that they are well informed about what they manage. They can present you data downstream the waste bin, what they collect, what they do with it, what they dispose. But when you ask about the leakage, where is the waste which is not managed, you do not get data. And this is, of course, the main problem of marine littering, is the leakage. So it's a kind of a coincidence or ironical. You go to a municipality, you admire the services provided, and then you go along the roads, you see waste in the drainage, in the waterways, you see uncollected waste, you see waste burning, but there's a system blindness. The local leaders don't even see it anymore. Everyone got used to it. And this was our problem. How do we now go to the decision makers to present a tool which is acceptable and not blaming, And it has to be a kind of scientifically and to open the door for good decision making, for understanding. And this is what the waste flow diagram is all about. We follow in a community, in a municipality, the solid waste management services streams, from the generation to the collection, transportation. We identify the leakage spots, we classify the leakage spots, the enablers, and this leads us then to a certain status where we can go back to the community and say, look, this is lacking in your picture, in your waste flow. This is incomplete. How can we improve your system? This is the main reason why we started. There are other tools available. So we do not measure marine litter. We measure the leakage footprint in a community in order to work. And since we have so many projects worldwide, this is a great opportunity to do something with the data. And at that step, I would like to hand over to you, Annika, to introduce yourself and to please go on.
Thank you very much, Johannes. And yeah, thank you also for inviting me. And I'm really happy to be here to present a bit more details about the waste flow diagram. I think Johannes really made it clear why the waste flow diagram is being applied. I would like now to go through quickly the main functions of the waste flow diagram, the sources of the data, how the data is handled, and to introduce the waste flow diagram portal, the online portal that we use for that. So as Johannes already said, the waste flow diagram visualizes the flow of municipal solid waste quantities within the waste management system. It quantifies the different sources of waste. It also quantifies where the waste goes, so which are the fates. Does it go into open water bodies, into drains? Does it stay on land or is it burned? And through this information, waste management planning can be informed because we see where are the main leakages of waste within the system. And it also entails a scenario function where different interventions can be modeled through the tool to see how this would approximately change the leakages within the city. And to see, to identify the leakages, we have to look at the source first. So the waste flow diagram looks at the uncollected waste, the collection system, sorting stage, transportation, and disposal. For the collection system and sorting stage, both informal and formal systems are being looked at. And how is this done? So at each of these stages, there are different factors that determine how high the leakage potential is in each of these stages. You can here see, these are called the leakage influences. And you can here see in the graphics one example for the stage of transportation. On the right-hand side, you can see different pictures of trucks. And there, if the study teams arrive in the municipalities, they have to see or gain the information through interviews and observations. Are the trucks, for example, loaded to capacity or even beyond? This, of course, increases the leakage potential, the risk for leakages in the system. Is the waste contained in bags or is it just loose on the truck? And are the trucks covered or is it just an open truck where waste can easily be flown away by the wind or anything similar? So these are like the factors that determine the risk for leakage potentials, and these are always connected to factors, to percentages describing the leakage potential. And then this is done for each step of the solid waste management system, and the waste flow diagram then calculates the leakage, the total leakage by multiplying the total amount of plastic waste going through the system by the leakage potential percentages for each of these stages. The next slide briefly brings it all together in the waste flow diagram system map, where we can see again the sources of the waste, the flows always marked by an F through the system, and also the leakages, which are here displayed with the yellow arrows downwards. So where does the waste go? First into the unmanaged waste and then finally into the environment. In summary, the waste flow diagram shows an overview of the whole municipal solid waste management system, including the amounts and composition of waste. where the pollution comes from, so the sources, where does it go, the fates of pollution, and how would the leakages change, as I said, if different interventions would be integrated. For example, if covered trucks would be used instead of uncovered ones. And all this can be visualized using Sankey diagrams. And we can see more of these Sankey diagrams that show always the flow of waste through the system and into different fates in the waste flow diagram portal, which I will now briefly introduce. Because the waste flow diagram started as an Excel tool, but we thought that it might have many benefits, as also the title of the session is the potential of digital tools and AI for the circular economy, or for reducing marine litter. We will now present the main functions of the diagram, the waste flow diagram online portal. The online portal has been developed to improve data handling, to improve the visualization of results, to enable data sharing, and also action planning. So now the complete data management can be done through the portal, and including the uploading and downloading of data. There's also a new data validation protocol where the waste flow diagram team validates the data that is being uploaded by comparing it to former case studies, by creating typologies of case studies. And this improves the data quality on the one hand side, but also enables learning from former case studies. Then in the online portal, there's also a scenario building function. On the one hand side for the interventions, as I said, to see the differences also visualized in the graphics if different interventions are being implemented. But you can also generate data for typical settings, for typical leakage profiles. For example, you can get a data set for an urban coastal region with more than 250 inhabitants based on former case studies. The online portal also enables the data sharing with other digital tools, such as the UN Habitat Waste by Cities tool, which we consider as really important because the waste flow diagram is like a first basis assessment tool. And there are many ones that are also more detailed and have a different focus. So it's really important to use these synergies between different tools. Of course, there's also training material online. And one function which is currently in preparation is a machine learning and AI use to recommend suitable measures to new case studies, according to their leakage profile and based on the knowledge that we have on former case studies. So this could be compared maybe to like functions of online streaming services where they say, okay, this show might also be interesting for you. So that would be like a recommendation function. This measure might also be interesting in your case, but that's currently in preparation. And to also show you a bit the waste flow diagram portal, I will really briefly guide you through the portal based on a case study in Malabon, Manila in the Philippines, just to see how the results of the waste flow diagram are being displayed in the portal. And therefore, I will switch here to the portal. Here, I hope you can see it. Yeah, I think so. I'm already logged in. That's why I already am here in the case study. And what you can see here is at first an automated report on the case study with the basic information about the site, the reasoning why the waste flow diagram has been applied, and then different visuals on the results of the waste flow diagram, on the municipal solid waste system itself, and also on the leakages. And here you can also access the flow diagram as I showed before, but this time directly with numbers. These are always tons per year. And also a Sankey diagram can be here accessed and also downloaded. You can have like a basic version or a complex version, depending on your needs. And also the results are summarized in here. And there's also a spotlight on the unmanaged plastic waste. But I think time is rather short. So I will move back to the presentation and the summary. So we see that the waste flow diagram is a proven engagement tool that is suitable for many purposes, including baselining, benchmarking, monitoring, and scaling to national leakage assessments. It helps tracking the progress of waste management interventions. If you do, for example, a waste management application before some interventions and 1 year or a certain time amount later, it can support the development of municipal solid waste management plans and national plastic pollution inventories. And we see that a fully digital approach is needed to really enable action planning against marine litter. And thereby the online portal facilitates data validation, access to data, the data exchange and visualization of results. And we also see a high potential of AI here to support data-driven decision-making using the data results and learnings from previous case studies. But of course, here, therefore, a good data foundation is needed. So we need many case studies to be able to really have good recommendations in the tool. And and in general, to increase the impact of digital tools for leakage monitoring, synergies between different tools should be identified and interoperability should be supported. Yeah, I think that's it from my side. Thank you very much.
Thank you, Johannes, and thank you, Annika, for the very comprehensive presentation. I think it's very powerful tool, I think, to really inform the local municipal solid waste management policy and then also actions related to that. Thank you so much. And then I'd like to, that we are running a little bit of time, but now I'd like to move on to Q&A session. And if you have anyone who would like to ask questions to all presenters today, please feel free. Yes, lady in the back, please.
Maybe regarding the Recycle X, so it's kind of, you also use the platform to trade on those as well? And is there any kind of IP related to that kind of data? The ownership of the data, what is like? So maybe this one first.
Thank you.
So the ownership of the data remains with the users, the one who is developing these kind of projects. We are the software developers. We are the providers of this platform for their usage, and all the IP related to this, if it is not co-developed, it is the property of the project developer.
Okay, maybe the last one. Regarding the economic value, because you trade and then you can use that data for generate some kind of value. So it can be a kind of a exchange and normalize the within the platform itself by input some data. Is it possible to do, or is already done on that?
This data exchange, of course, do happen, but since it is all end-to-end encrypted, there are specific stakeholders only who will get the access to the data, and all these data are stored in the encrypted form. We use the zero knowledge proof kind of technologies to store those kind of data. So it doesn't, expose the data to the public, but it also shares the information what is relevant.
Thank you. Can I also ask Tomra as well? Or maybe other people want to ask first?
Please go ahead.
Okay. So with your solution, so how high it can take regarding the contamination? Because you said it's high level that when the garbage come with a lot of contamination, it can go up to quite high level. So any percentage that is it possible to share?
Well, it's actually difficult to give you a quantified number about how much contamination we can take. Basically, for the sorting, you are looking at two parameters. One is for the sorted out material, targeted material, you are looking at the purity. Right? You want the purity to be as high as possible. And then you have another parameter is sorted out percentage. That means if you have a targeted material, you want to try to sort out as much as possible. But these two parameters are kind of conflict to each other, right? You cannot have both of them at very high. So you always need to make a compromise. If you are aiming for more purity or you are aiming for having more materials being sorted out. So then this in connection to the contamination, right? There is a linkage there, but I don't have any data can see, with this percentage of contamination, you have a purity. That's why actually for TOMRA, we have a lot of testing centers around the globe. So whenever we are not certain, we need to put some samples, material, into our testing center, then we can give you some number after the test. Yeah. I hope that answers your question.
This kind of information is like, can you kind of do some value estimation from those? Because you already teach them what are what are the material, and so can you kind of likely to gesture some kind of valuation regarding those proportion of those? Is it possible?
I think technically it is possible. Maybe, for example, if we work with RecyX, with the composition data and with the information of the market value of the materials, yes, then definitely it is possible to make a calculation on that, yes. But then, of course, for the recycling industry, the price variation happens almost on every day. So you need to have immediate data on the market price for the materials, yeah. Yeah.
And just one last one. So it's like when we try to use this thing as a larger scale, but for Southeast Asia, sometimes we do have informal collector who already collect some out of it in order to make this economic. So any solution that TOMRA's try to see is for some informal sector in order to combine this kind of solution at all? Thank you.
Yes, actually, I come from China, right? In China, we have a lot of customers in for example, PET or other rigid plastic recycling. Many of them are quite large volume. We're looking at if it's PET bottle recycling starting with 30,000 tons a year, or we have the biggest customer works on 400,000 tons a year. Then they actually all work with informal collection. Right? You have different levels, right? You have the waste pickers from the street. They go to some kind of junk shop. Then you have the small baling station, then the larger scale baling station, then to the recycler. So our machine used to mostly be deployed at the recycling facility, right? When they get the big bills come in. Then they have the economy of scale, they use the machines. But we also now start to see a trend that, the sorting automation start to move to the upstream. Some of the small baling stations also want to have automation. Well, of course, for one reason is in China, the labor cost grows, right? You want to have more automation. But secondly, is also in this region, we start to see a lot of countries now promoting, rPET, for example, for food packaging, right, bottle to bottle. Then you really need to have a high quality of the material, and you also want to keep the material in the value chain as much as possible. So then a lot of this informal collection, they also need to upgrade themselves to be able to supply high quality feedstock. Then they also can make a bit more income for whatever they picked from the street, right? So we see a good connection in that way. So and also on top of that, we are seeing, in the extended producer responsibility legislations, we hope that, the deposit return system will be combined for the beverage packaging. Then you have a high collection rate of high quality material. For that, I think, for the informal sector, the waste pickers, they probably will have to pick less because the, return rate is high, but then for one bottle they pick, they'll get more money, right? The deposit value is much higher than the material value. So that's also, we see a way that they've been offered maybe a better revenue with the DRS system, and then that can also offer some new green job opportunities for them. Yeah. So we see that's kind of just an inclusive transition for the informal sector. Thank you.
Thank you very much. Any other questions from the floor? Not really. So in that case, there's a front hand. Yes, please go ahead.
Thank you. My name is Eva, and I have also a question regarding RecycleX. And in Europe, there was a big discussion recently about the EU supply chain law, and which requires European companies to respect human rights and environmental standards in their supply chain. And there was partly a huge criticism from the private sector. And I wanted to ask what challenges you're facing regarding scaling up your service and how you respond to, skeptical partners. Thank you.
So I would say actually policy instruments in some way or the other has helped a lot in reaching to the last mile. So the policy instruments could be of any sort, like upcoming plastic treaty or EPR sort of instruments. They do have some obligations on the producers or the brand owners, I would say, but ultimately the aim is to reach to the last mile, right? And it should be measurable, equitable, and verifiable. Of course, there have been so many claims that were made that so and so, recycled content is there, or we have used sustainable material, etc. But since there was no provenance, that's how these regulations come up. And then that's how they were able to, some way or the other, have now tool to equitably distribute this financial aid, if at all, that is coming in. So that actually adds up to the overall scheme of things. So it has actually been helpful when the regulations of this sort come in. But of course, there are these multilateral organizations that do take up these kind of initiatives on voluntary basis as well. So that actually helps a lot. I hope that answers. Thank you.
Any other questions? Please go ahead.
Just for the waste flow diagram. So it seemed like, with the system, so you use just the data of the photo, or someone putting in the data for you in this sense?
Well, in the beginning, we help in our development cooperation work to identify many samples where we work anyway. Usually we work with municipalities and look into the systems for system enhancement. And by doing so, we realize we gather so many data. And now when you think about, these data can be correlated, they can be looked at in time, they can be sorted in clusters, coastal, urban, tropic, correlation to GDP, you can do a lot. And in the end, these data can provide evidence, they can result in information which can be guidance for LGUs. So basically, we from GIZ we don't want to do this in every LGU on the planet. If the portal helps, that you can already get a kind of information by asking what type of municipality am I and what have others done to solve the problem, to address the problem, then we save a lot of efforts. And that's basically what we are after. So this waste flow diagram portal may enable users, which could be municipalities, to get capacitated, to understand better, and to get directly access to where am I and what can I do, what should I do? And this is basically then the benefit for many municipalities to help them to strengthen their capacity and to act better on reducing waste leakages. This is what we are after. And since I'm not a digital expert, I believe if we work together with science and universities, there's so much more value in these data, which has to be mined and can be useful for policy making, for national governments, for regional, for economy, even for the private sector. A lot of insights can be lifted up. Last not least, for United Nations Sustainable Development Goals, we may also contribute.
So just to facilitate the operation, because if you mentioned about the data on the time, so it can also do it as a kind of passport as well regarding the traceability, as you mentioned, and also some of the information, because as you have the logistic, which means at the end, if that plastic has been recycled, so it could also collect the emission in terms of the energy consumption, and it can go down to the tonnage at the end. And when those can be recycled, it can go back to another cycle of remake of that plastic type as well, right? So those kind of data that come into this, because now we're talking about the cradle to gate information, but then this can help support some cradle to grave and cradle to cradle in that sense, right?
I agree. There's probably many applications which I do not see yet, but I can assume when we invite experts from science, from the different sector, even social data, behavior data, intercultural settings, there's a lot in it. So that's why we came to the conclusion we collect so many data now. Better think about what we can do and to make it visible and to make it to provide a tool. And I think GIZ, as long as we get the contracts to continue, we will be happy to continue with this work. I hope that answers.
Thank you so much. Yeah, a lot of great job that you guys presenting today. Thank you.
Great, thank you so much. Do we have any other questions from the floor? Okay, so maybe then I can ask the last questions for each panelist. So first of all, for the TOMRA, I was just wondering about like affordability and then also maybe this compete with the informal sector, to be honest. And then I'm just wondering, like, for example, like how affordable it is in the low to middle income countries. That is one question. And then I was just also wondering about your technology recyclers, how that digitalization and so on, how that could be, the possibility of the technology to become like, the tool for the EPR regulation enforcement, for example, when the countries are coming up to really, for example, set up like this is the minimum wage that you have to pay for the informal sector and so on. So that's something that I'd like to ask. And then lastly to Annika and then Johannes, I'd like to ask like how those data can be also utilized for countries to develop national source inventories and then also national action plan. Maybe just one or short words because we only have 5 minutes left.
Yeah. Okay, that's a great question, but it's also a tricky question, right? Affordability. I have to say, our machine is not cheap, right? But then, if it's fit for purpose, then, when you have the scale of the economy, then it's not expensive. On the other hand, right? So you need to find a proper use for the machine. For example, for the sorting machine, it's best used when you have the volume. And you also have a request on the purity, or if the input material is very complicated, then human hands, human eyes, they probably cannot handle that with the speed, with the volume, with the accuracy. Then the automation and the NIR or the AI plays an important role there. So that will be my answer. And how it works with the informal sector, I think right now, we see most of our sorters are used in the PET and the rigid plastic packaging recycling sectors. That's because without the legislation in many regions, the economics can work, right? But then, if you have the EPR, that means, you have the producers will pay a fee into the system to improve or build the infrastructure for collection, sorting, and recycling. Then, there is, as a quote from the Ellen MacArthur Foundation, again, then you have enough dedicated and sustainable financing into the system. Then, our machine is not expensive anymore. And the informal sector will be paid in a much better way because, on top of the material value, there is additional financing into the system. Yeah.
Thank you very much. Please, Surbhi.
Yeah, so conventionally, what happens is when we generate the EPR credits or the plastic credits as a result of EPR, it is generally associated with the recyclers. But I'll give you one example of our good friends. They are, of course, here. They are our clients they are the project developers for Evergreen Labs is their name. So they in Philippines they have completely turned around this narrative. So they have enabled the cities, the municipalities to participate in the EPR programs, which was predominantly the recyclers or the aggregators were behind these programs. So they have brought in these municipalities, the barangays, the LGUs to participate in these kind of programs. And using these traceability tools, they are actually able to record and document every single kg of plastic that gets collected, sorted, or recycled into the new product, and thus diverting it away from the landfill. And every kg of plastic diverted away from landfill generates the impact, and that impact is tokenized. And that is placed in the digital wallet, but only to be claimed once. So that actually, once that impact is monetized, there is a way to track the entire equitable distribution to all the stakeholders through this tool. So that's what it enables. Thanks.
Great, thank you so much for the elaboration.
Annika, you want to go first or me first?
If you like.
So not ladies first, I go first. Yeah, I see, maybe from the perspective of the countries we are working here in the region with ASEAN, I see so many benefits. All countries have a national plan of action on marine litter. This plan has many intervention areas and it has targets. So when I only to take the sample of the Philippines, we say in 2040, marine litter problem is maybe not solved, but we are doing so much better. But then how do you know? So our tool may give one research component to go into and to see how can we provide evidence for the national government, how can we come up with comparing different data to see where we are. So here, national data collection, evaluation, we can just give a contribution that the national governments get more tools at hand. At the same time, we're providing for the National Action Plan also a lot of data and intervention for the stakeholder awareness and collaboration to open this field. And last not least, in the end, the validation of marine litter needs to discuss how do the countries establish tools. So our tool to give data in time, or we can give data in time how waste leakage develops in communities. Maybe one approach to say, since we cannot measure the marine litter, this is very complex. In the Philippines, we have marine litter from Malaysia and Indonesia, but we can measure on land. This may be one way to look into it in the future. So I see for the countries many benefits, and also for providing data for the needed digital use in the national governments. But please, Annika, maybe you have to add other benefits I have not mentioned or seen.
Yeah, maybe one real technical note on how this aggregation on the national level could work. So, and it has also already been proven in some cases. So you can also classify different types of regions within a country, and then you go on and apply the waste flow diagram for the biggest cities, and then for some exemplary rural areas and semi-urban areas. And this way, you can estimate the leakages for other similar areas to also get a better picture on the national level. So maybe more of a technical note on that, on how the waste flow diagram can also inform national policy making on marine litter.
Thank you. Thank you very much for your very insightful comments and presentations. I think, unfortunately, we are running out of the time. So here we'd like to close the session with a note that the digitalization is a tool, but we can, if we use it in a really better way, in a very good regulated way, I think, and then also it's going to be a really great tool to advance the important agendas such as just transition and then also the improving the recycling rate and so on. And also those data, we also looked at the data from the city level can also inform the national policy to really prevent and reduce the plastic pollution, really pointing out where the sources and then pathways of the pollution happening along the waste management also. Thank you so much, and thank you for your attention.